Okay. Hi everyone, it's a pleasure for me to present our next guest. He's been attending the stage of OpenFest for over 10 years. And once again, he has came from Netherlands, especially for you. Please welcome to the stage Merlijn, with applause.
Thank you very much. Is the audio good? Yeah. Okay. So I'm here to talk to you about microfiche digitisation at the Internet Archive, and specifically how we're trying to digitize everything at scale. So a little bit about me in the Internet Archive. I was already introduced, but I've been coming here for a while. I used to be a member of the InetLab hackerspace. Well, I'm still a member of the InetLab hackerspace, but I used to be a member of the Amsterdam hackerspace. And I've been working for the Internet Archive for quite some time now. I will start this presentation with an introduction to what microfiche is, how we tried to digitize it in the past, why we want to digitize it, and then dive more into details of what we're currently trying to do, what challenges we're facing, and finally what the next steps are in our digitization process. So, as she said, I'm from the Netherlands. I don't live in the Netherlands. I spend a lot of time here and some time in Croatia. And I work remotely for the Internet Archive. They're based in San Francisco. They're a non-profit organization that has existed since 1996. And they are first and foremost an archive, but they're also very much a library. So they started by archiving the World Wide Web. So it's called the Wayback Machine, and you can go back many, many years ago and see what your university website looked like, what the news websites were writing about 20 years ago. And they try to do their best to digitize or archive all the web pages on the web. Of course, all the web pages is impossible, but they try to do a very good job at that. So that's what most people know them for, but they also digitize physical material. And that's most of what I work on at the Internet Archive. So, what is microfiche? Has anyone ever seen microfiche in person? 1, 2, 3 people, 4. So microfiche is similar to microfilm, which is maybe more known from like James Bond movies or something. It's basically a lot of material scaled down and saved on a piece of film or fiche. And this is commonly referred to as microform. And here is a picture of a microfiche as we digitize it. And it's, you can see there's some text above there which describes what this material actually is, and then you can see there's many pages with text on the microfiche. So you might wonder how big this is. Well, it does say micro in the name, and it's about an A6 postcard. So if you buy a card, you want to send it to someone, that's about how large this is. And as you can imagine, looking back at this picture for a moment, you have a postcard this big, and there's like 60 pages on them. They are very, very small. You know, every page is smaller than my pinky. So it's basically something that libraries started using, I think, in the 1960s to store other collections that they had that were falling apart. So you can imagine they had newspapers from 1900s, and libraries kept them. But newspapers are very big, and they're mostly meant to be read that day, maybe next week, but not 50 years from now. So these newspapers, they start to fall apart. And the idea was to photograph all the newspapers onto film or fiche, so that you can take a whole room filled with just newspapers, piled all the way to the top, and condense it to like one small box of microfiche. And this is a pretty neat idea, but the material comes with problems, because of course, you would have to go to the library to read the newspaper just the same, but if you want to read a microfiche, you can't just hold it and look at it. It's way too small. Even with a magnifying glass, you can't really see it, so you need these specialized, what they call microform readers. And that's a big screen with a glass table and a light below, and then you can read like certain pages of the fiche by moving it around. And what we want to do is to digitize them in such a way that you can just go to a website and read it on your computer. So why do we want to digitize microfiche? Well, just as the newspapers and other collections of libraries, they start to fall apart, microfiche has the same problem. In ideal conditions, it can technically last for 500 years, according to Wikipedia, but in practice, ideal conditions are not really to be found anywhere. So the microfiche that we have is already deteriorating to some degree. You'll see different, well, it's a grayscale thing, but you'll still see certain parts get much darker, or you know, things just get harder to read. As I said before, the material is not usually easily accessible, and even if it is accessible, they won't always let you get to it. Usually, the microfiche are duplicated, so several universities will have the same fiche. That was just another easy way to distribute the information. And another reason for us to digitize these things is that we have large collections of government documents.
Can you bring your mic close?
A bit closer? Is this better? Okay. So we have large collections of US government documents, and most of those documents are in public domain. So you can imagine US government, they had agents all across the world monitoring what happened in the political sphere, what happened in certain countries, and they would write about this. And they were paid by taxpayers of the US, so normally all these documents are in the public domain, which means that if you digitize them, you can share them with the world without any problems. And we have a lot of microfiche that is not yet digitized. So the Internet Archive takes a lot of physical donations of books, records, microfiche, microfilm, and then we digitize them. So a lot of libraries have donated their microfiche to us, and we are trying to make a very big collection of government documents of microfiche so that we can freely share that information with the world, and they can learn about, you know, what their government was doing. And this is a part of what the Internet Archive calls the Democracy Libraries project, where they try to collaborate with a lot of libraries and archives to bring as much government documents as possible online, so that people can, as I said before, figure out what their government is doing, how the democracies operate. So we've tried this a few times. I'm going to talk about the second attempt that I was marginally involved in the first attempt of digitizing microfiche, but it was mostly my colleagues doing it. We had experience digitizing microfilm, which is films of the same stuff, but you know, not a single fiche. And we used a commercial scanner for that, and that worked out pretty well for us. And the same company offered the microfiche scanner, so we figured we would try that out. The problem is that it's a Windows-only thing. You have to buy their computers, and then you have to use their Windows software to digitize everything. We tried this for about half a year, and it worked okay, but there were some problems. So the system used a line scan camera. Is that concept clear to people, what a line scan camera is, or does anyone know what a line scan camera is? Basically, the idea is if you have, say, a printer at home where you can scan your documents, that's basically a line scan camera. It just scans one line at a time. And then if you add up all those lines, you eventually get your document back.
Sorry, can you go to once again?
Sure. Better now? Okay. I hope I was audible enough before. So a line scan camera is basically what you have in a flatbed scanner. It's just a line on a motor that slowly moves and scans all the material. And that's what they also did with microfiche. So it's a very line scan camera with a very high resolution. But the resolution was not high enough to scan the microfiche in one go. So if you can imagine there's a postcard like this, they would scan one line, then they scan another, and another, and another. And then in the software, you could try to find the pages and crop them. But if the pages were in between the two rows, you would have to scan it again, which is very frustrating. And it also makes it very hard to deal with a fiche that's just a big map of, you know, where they found oil, or infrastructure maps, or just geographical maps. You cannot get them on a single row. So that made it very hard to digitize these. But the system had a very nice high resolution because it did these rows as opposed to a whole fiche. I already touched on some of the downsides, but I have a whole slide dedicated to them. As I said, big maps are a really big problem. And in general, because it was a Windows software that we cannot change at all, it really forced our hand in how we digitize things. So we had to go through their software, make certain identifiers there, scan it to a certain directory, run their program to output the images, then we can do something with the images, put them online, and it made it quite tricky. And because of the overhead in starting a new digitization project with the software, we have decided to scan many microfiche into a single project, even though they might not be related. But again, that was to try to make it faster. And then because we didn't really have a way to fill in metadata for these, we started doing that in Google Spreadsheets, which meant that the metadata was again in a different place than where the bits were. We eventually stopped doing it this way and started again this year with the lessons learned. And the goal was to develop our own microfiche scanner. We wouldn't be making our own cameras, obviously, but everything else would be basically, let's just figure out what's the best way to do this. We wanted to have a high resolution image of the fiche so it's perfectly legible, because we have 1 million or more, so we want to scan them only once. We don't want to scan them again 5 years later because we decided, oh yeah, the resolution wasn't that good. And then our idea was, okay, let's just make sure we get a single picture of the whole fiche. And after that, we'll figure out where the pages are, or whether it's a map or something else. And we also decided that the way the microfiche are organized that we have is just a postcard envelope with microfiche in them, and there can be just a single fiche in there, or 5 or 10, but they're always part of just a single issue or a single newspaper, right? So it's never 3 newspapers in a single envelope. So we decided, okay, let's just digitize 1 envelope at a time, because then we get a single newspaper for a single day or a single issue, stuff like that. We wanted to do everything on Linux, no Windows, mostly written in C and Python, and we really wanted to be able to fix mistakes that humans made after we digitized it. So we don't want to throw away the high resolution image the moment we've made pages out of them, because then we can't fix it if there's something wrong. So I will briefly explain some terminology. Basically, what is an Internet Archive item? An Internet Archive item is data that we store, and it has a unique identifier, it has a name. And other than that, it's basically just a set of files and directories that get uploaded, and certain operations can be done on them. So if you know the name of the identifier, you can go to the browser and you can just view it. You can see if it's a public domain book, you can just read it, or you can download a PDF of the book. Or if you have access to the collection, you can change the metadata of the book, you can change the title or the way it's displayed. Obviously, we have an API to interact with all these items. And finally, everything that's done to the item gets logged into one big catalog, which is the Internet Archive catalog. And that gives you a history of everything that was ever done on that item. The typical interface is HTTP, both for downloading and for uploading. Yeah, and I guess an interesting thing is that depending on what the media is, it will present itself differently. So if it's a 78 record or a long playing record, it will be a music player. If it's a book, it will just be a book reader. Or if it's a video, it will be a video player. Okay, so we tried to build a different machine. So the previous setup with a line scanner that just moved the fiche, or the scanner moved over the fiche in one direction, right? There's just one dimension here. And we decided to try 2 different approaches. We would try to use a line scanner and scan the whole fiche in one scan, and to use a area camera, which is really what you know as a normal camera, which just takes a 2D picture. So we have two different cameras and 2 different setups that we're building. And for this, our idea was, let's keep the camera still for the area camera and move the fiche around, because we cannot take a single photo of the fiche. That would be great, but the camera resolution simply isn't high enough to take this really, the really small material on the fiche and digitize it in one photo. So we built something called linear stage, which uses motors to drive something around. So you can imagine the fish is lying on a table, and then it just moves like this, and the camera stays in the same place. So then you get separate shots of different parts of the fish. We're still working also with the line scan camera, but so far we've had the most success with the area scan camera. And of course the fish needs to be illuminated because we want the exposure time to be short. So there's a tracing light table on the stage, and then there's a fish on top, and then a glass plate on top to push the fish down. Because if the fish is not completely flat, things will be out of focus very quickly. The camera that we use is called a Vueworks VMP604MX, and it requires a specialized PCR card just to grab the camera data. It has a native resolution of 151 megapixels, which is probably like 6 or 7 times more than regular consumer cameras do, but if you have a very good camera, you might get a 50 megapixel sensor. But the sensor of this camera is really big, which means that it captures the data better than consumer cameras do with smaller sensors, because at the edges things start to kind of fall off. Additionally, the camera has something that they call a pixel shift, which is kind of a confusing term, but basically what they say is we can take either one photo at 151 megapixels, or we can take 4 photos of the exact same thing, but move the camera around just a little bit, like a couple microns. And then these 4 shots we will combine into a single image to get a higher resolution capture of the material. And this way they can reach 604 megapixels or 1.3 gigapixel. If you digitize a microfiche using their pixel shift technology, where a single photo is a 604 megapixel, a single microfiche image will then be 2.1 gigapixel, which means that 1 pixel is about 2.7 micron, also known as micrometers. So 1,000 micrometer is a millimeter. And a human hair is about 75 microns. You can imagine how small these things really are, you know. And even if you digitize the fish, a letter is probably 15 by 15 pixels. So it's really, really small stuff. And this makes it all very, very sensitive. Our XY stage is built with an Arduino and a couple stepper motors, with open source firmware to drive the stepper motors and interact with it over on the PC. We've also tried to use consumer cameras as opposed to the Vueworks camera because it will be much cheaper. And you can do the same thing, right? You can have an XY stage and it just moves a little bit, and the consumer camera makes like 15 photos per row. But it's not feasible. Like, you don't just add up the megapixels of the photo and then say, oh, okay, we just need to make 6 times more photos. No, you need to make many more. Because with a consumer camera, you need to use a macro lens to get the detail that you need, because the sensor is much smaller. And then near the edges of the photos, the lens starts to deteriorate, and you can really only use like the center part of the photos. You have to make really a lot of photos. So we stopped trying to do that. This is what it currently looks like with our camera setup. So you can see that there's a whole big support at the bottom, and then there's a linear stage with 2 ball screws in one direction, and then another ball screw mounted on top. And these ball screws, they have a stepper motor so that when the motor turns, the ball screw moves this way or this way. And then there's a light table on top, a microfiche on top, and then a piece of glass. And then above that is the camera with a specialized lens. This is another shot of the fiche holder that we added recently. So basically, you open the glass, you put in the fiche, you close it, and you click a button. This is our other setup, which looks somewhat similar, but this is the line scan camera that we're building. You can see it's the same idea. There's a single stage, the fiche moves like this, and the camera just captures a line during the whole movement. This is more tricky to do, which is why we haven't finished it yet. The camera itself is cheaper. We might technically get a better resolution, but because of how small everything is, and any vibration at all is going to cause trouble. So after a while, we were able to capture a whole scan of a fiche, but the text would kind of go in a wave, right? Like something went wrong, because even like a couple micrometer offset in the ball screw is enough to throw off your whole capture process. And in addition to that, the stepper motors, they have linear encoders set up that will provide feedback of the motor's motion to the computer, because the camera has to compensate for the motion. The motion is never one smooth motion. If you would just use the motor without feedback, you'll get stretched out parts of the scan as well. So the camera that needs to get feedback as to the motion of the motors. So we were able to capture a card, but not really at the quality that we wanted. We're still going to try to figure it out, but right now we're making the area scan work first. Okay, so what does the digitization pipeline look like? Right, we have it working now, and how does it work? Well, it obviously starts with the digitization of a single envelope, which can have one or more fiche. So if someone sits next to the camera that I showed earlier, they click a button in the software and they put the first fiche on, and they click capture. Then the camera makes a photo of the fiche. The stage moves, it makes another photo, stage moves again, another one, and another one. So a total of 4 photos. And you might remember when I said what our goals for this new project was to get a single picture of the whole fiche. But we're now taking 4 photos. So we need to process that later to make that into a single image again. But that's a costly process, so we don't have the person scanning the fiche wait for that. So that's a separate part in the pipeline. So then the next step after a fiche is digitized is to print a label. That label is stuck on an envelope where the fiche is in, so we know exactly, okay, this is the archive.org item with this identifier name, and this is where we can find the bits of these fiche. After that's done, the person will start doing another microfiche, another, and another, and another. In the background, we will then pick up the fiche they just finished and start processing it. And most of the processing really means, okay, we have these big TIFF files that are all 600 megabytes each, and we want to make them into a single file of microfiche. How are we going to do that? And this is where we employ a process called stitching. And you might think, well, you know, you just take the 4 photos, you kind of align them correctly, and you're done. No, it does not work that way, because everything is so small that it's basically impossible to calibrate your linear stage so that when it moves a bit, that there's 0-degree rotation, right? Even if if you just get it off by a half a hair, then the fiche will be offset a bit in between the 2 photos. So you need to adjust for rotation, you need to adjust for the fact that they're just not exactly in the same place. And the way this normally works is very similar to how people make a panorama photo. Does anyone know what a panorama photo is? Okay, most people do. Basically, you make a lot of small photos and you turn it into a big, big photo. Usually very pretty. So we employ the same techniques. We do control point finding, stitch it together, and then upload the image as a whole, as well as the 4 shots to the Internet Archive. After that, we do some processing on the fiche, which I'll get to in a moment. Then we have a human review the work. And finally, we process the item in a way that becomes accessible on the web, that people can use a web browser to view it or download the PDF or all that kind of stuff. Okay, so I've basically covered this already, but very quickly, we capture the fiche with our own software that runs on Linux. It's called Confusingly Archive CD because the first thing I worked on was CD digitization, and we kept adding things on to the software and never decided to change the name. But it does a lot more than CDs. And the capture itself is done using the driver for the camera that works on Linux. They offer SDK, and I built a C++ program to do the captures with the camera in such a way that it's basically a Python shared library. So you just import it in Python and you get a nice image as a result of the capture. So it's pretty trivial. And I had to implement their pixel shift technology because the camera just gives you 4 photos and then tells you, good luck making this into a single photo. And just to make it clear, we use the pixel shift technology by doing 2x2 pixel shifts, so we get 4 shots for every photo, but then we also make 4 shots of different parts of the fiche, so really we make 16 photos. And then, as I explained, the human operator take a fiche, they put it on the stage, they scan the previous label so that we know what the next name is going to be, and we print the label when we're done. This is what that looks like. So you can see a fiche here in an envelope. This was donated by the Evergreen State College Library in Washington. And below that you can see a small label which contains the number of the envelope, the specific box that this is in, and a link to the Internet Archive item in the form of a QR code and text at the bottom. This is another picture of the same thing, but basically these are the 4 shots that we take. So if you would just take the 4 images that we make, it looks like this. And you can see there's overlap on all of the borders. That is intentional because we need this overlap to stitch things together. Yeah, so how does the stitching really work? Basically in a very similar way to panoramas, except that usually panoramas do a lot more complicated things and they don't really care if things look a little bit off, whereas we really want it to look very good. Because even if the text is a bit skewed or just there's a seam, it's stupid, right? That kind of defeats the point. So we use software called Huggin or Pano tools, which is used for making panoramas. And what they do is they employ certain computer vision techniques to find what they call control points in all the images. And those are essentially supposed to be points that will that are a good description of a feature in the image. So if you have shot A and shot B, and there's some overlap here, then we hope to find control points here and here that have the same features. And then we can figure out exactly how to align those images. There's different algorithms for it, SIFT and SURF, and a newer one is ORP, and they all basically do the same thing, but they work slightly differently or faster. And then there's an algorithm called Ransack to actually take all these control points and filter out the ones that are actually not control points or are false positives. We started by just doing what the panorama creation does, and it's really slow. You know, it takes like 5 minutes on a 24-core machine to process a single image and stitch it together. So I started looking, okay, why is it so slow? And we figured out the blending process took most of the time. We found a different tool that blends images together, and now we use a tool called Multiblend, which is much faster. I had to work with the maintainer to get it to support grayscale images, but now that all works. Another tricky thing is that Huggin project files, they contain all kinds of information, but it's not in JSON, it's not in XML, it's just kind of text on a line. They don't really say what is what, so you have to grasp that and figure out how to parse it. It still takes a while to stitch, but it's much better, and we're probably going to move some more tasks to the GPU to do it even faster. Okay, so once we have stitched all of this together, we've uploaded it to the archive. There's an automated process that then starts to take this single image and create a much smaller thumbnail image so that we can view it easily, because a 2.1 gigapixel image, even if it's encoded, still takes a long time to download. So we make it much smaller. We encode it as an AVIF thumbnail, which is basically a modern version of JPEG. And we use that later so that we can view it easily in a web browser. The other thing that we do is we analyze the card with computer vision to try to figure out where the pages are. And if we found the pages, then we try to deskew them. So if a page is photographed on a fiche, it might be tilted. And then you would have to read the text like this while you're looking at the computer screen. So we try to fix that just to make the text straight. If you graph the process of finding the pages, it looks like this. You basically just, let me quickly go to a Microfiche photo here. Here, so if you look at this, you can basically imagine if you count all the white pixels in both directions and you just graph them, you'll see that, okay, this line has nothing, nothing, nothing from the left, and then suddenly there starts to be a lot of white pixels, and then again there's nothing because there's a black line separating these pages. So if you graph that and then find the peaks in those graphs, you basically find where the pages are separated. So that's what this graph shows. Never mind the axes, it's just about the lines and the peak finding. So we use some math to find the peaks, and then suddenly we kind of have an idea about where the pages are. And it looks like this. I'm not sure if it's visible, but basically every page now has a red rectangle around it and a number in it. This doesn't always work perfectly. We still have to improve it some, but it was good enough to get us going. So after we've done this process on the server, it's finally time for a human operator to see what the crops or pages look like and to review some of the work. And something I haven't talked about at all yet is the metadata surrounding these fiches, because it's great to have a fiche digitized online, but if you want to find a newspaper from a specific year on a specific date with a specific newspaper title, you need to find them, right? And if we don't have the metadata for them, then you can't find them. We'll have the bits, but nobody can find them. It's like it's locked somewhere in a storage anyway. So the next step is for a human operator to fill in what this material actually is. And because these are pretty big collections of, in our case, government agencies, we've created a collection per government agency where these fiches go into. So the first thing someone does is they say, okay, no, this is the Foreign Broadcasting Information Agency, and it's their collection on the East Asia countries in 1980 to 2000 or something. And then the human operator, they fill in the date, the issue number, and the volume, and then everything else, catalog numbers and product codes, which are basically just technical terms and how you can find this exact thing, are usually completed automatically. We also assign a title to it, which in this case is FBIS Daily Report, East Asia 1994-01-19, Volume 94, Issue 12. And this is a web-based tool. Yeah, so basically, like I said, metadata is done at this stage, and it might be different when we're dealing with non-government documents. You know, newspapers don't necessarily have an agency that publishes them, so that might just be the name of the newspaper, but the name of the newspaper might change over time as they get acquired. You have to deal with all of that stuff. But basically, for the government documents, we have the metadata listed below, which should be enough for people to find all these things. So the tool that I showed just now, where humans can enter the metadata, is written in JavaScript. It's a single static page, and the idea is that people can go to their browser, fill in the item identifier, and they'll just get everything in front of them. The fiche, the crop boxes, the metadata, they type it in, they say I'm done. Which is very different from the spreadsheet approach we had before, because then they wouldn't even be able to see the fiche. They'd have to go somewhere else to find it and look, okay, what does it say about the fiche? So that was complicated. But the cool thing about this is that it actually runs Python in the browser, because the Internet Archive has an API, but almost everyone uses our API through the Python library. And I didn't really want to write a JavaScript library for the API. And we already have a very nice Python library that does it. So we decided, can we not just like run Python in the browser and call it from JavaScript? And the answer is yes. Now you can. So with WebAssembly, you can use a project called BioDye to basically run most Python modules in your browser. So we did exactly that. We had to fix a few bugs, but basically we now use our Python API from the browser, and it was super fun. Yeah, and as I said, this tool allows editing all this data. Then the final step of the digitization is the processing. So we know where the pages are, what their skew is on this whole big fiche. And now we actually need to extract the pages out of that, make it into a book-like thing. And that is done by extracting the images, doing any contrast adjustments so it kind of looks a little better. You know, if the image is very dim, we just take the black and white value and stretch it a bit out so everything looks a bit brighter. We convert it to a JPEG 2000 image and make a zip file, and that is the book. And after that, all of our processing runs in it. So OCR, which allows you to search within the book, or it means that when you go to the archive and you search for a sentence that occurred somewhere on this microfiche, we'll show you, well, you searched all the text in all the Internet Archive, and we found this specific sentence here. You want to click on it and see it. I've done an extensive presentation on this 2 years ago, I think 2 years ago, on OpenFest. So if you're interested in that, you should check it out. Yeah. So what are the challenges here? I've alluded to some of them, but basically the hardware deals on with such small detail that everything matters. You know, if the stage is tilted a little bit up, so this is higher than this point, your focus is just a mess. So the pages in the center might look okay, but on the left they're out of focus, on the right they're out of focus, and you're not capturing it correctly. But so we tried to fix that. So we took, you know, the leveling tools that have a water and a bubble in them. Put it on there, and you kind of look like, okay, well, yeah, now it looks pretty good, and it's still not as good enough. Like we scanned a whole bunch of fish and realized, yeah, it's still a little bit out of focus on the right side. Then when it moves to the next shot, it's even more out of focus. So something is still not right. And then a colleague told us buy a laser alignment tool. So there's just a laser that points at that thing, and then we realized when we put it in there, oh yeah, it's actually not completely level. And of course, it's the analog world, so you can never get it to be completely level, but it needed to be more level. And once we did that, it looked better. Another thing we ran into is that the stage can be rotated like this, but also like this. And if that's not, if there's enough rotation in there, let's say 0.1 degree or 0.2 degrees, that can throw off the stitching. Because before, when I wrote the stitching, I assumed like, we don't have to adjust for rotation, you know, it'll just stay the same between 4 photos, but no. Even a 0.1 degree rotation throws everything off. So I made the stitching adjust for rotation as well, because we just couldn't get it to the point where you just make 4 photos and you stick them together. And of course, that means that our stage is 5 degrees of freedom. Like I said, there's the roll, pitch, and yaw, but also it can move in this direction and in this direction using the motors. It just can't move up and down because we have no need to do that. There's still some other bugs to solve. The camera sometimes includes bits from the previous photo, and I don't know if that's a buffer management problem on my side or in their driver. It doesn't happen that frequently, but we'll still have to fix it because it slows us down. Here's a picture of the laser alignment. This is what it looked like before we aligned it. Well, we used another alignment tool, but not a laser alignment, and now it was much better. You can still see that there's a little bit on the right side that's not exactly in the center, but it was good enough to get the focus to be correct. For me, so far, the biggest challenge was stitching. I tried to do stitching in our previous project to take the rows and stitch them together, and it took forever. And I wasn't sure if it was going to work this time, but we have a lot more overlap now, and we have a lot more information about where everything is. So I spent a lot of time getting that to work. There is a user interface called Huggin that you can help to visually debug the process. So even if you run all your control point finding on the command line, you can still open the project in the GUI, and you can see, oh, okay, so these are the 2 images, and these are the control points that match. And if there's no control points at all, then you'll realize it's not going to stitch well. Knowing whether the stitching worked at all is tricky. Like there's still 0.5% of our items where we just have the first shot out of the 4, and the stitching said everything's fine, but everything wasn't fine. So I'm going to have to do some parsing on the project files to see, okay, is there actually enough, are there enough control points? Do they have enough overlap or not? And probably look at the resolution of the images at the end, and if it's too small, we realize something went wrong. It was also very hard to get rid of stitching artifacts, especially when our system wasn't as aligned and calibrated as before. Stitching looked a little weird, and there was some heuristics in play initially where it just stitched at the wrong place, and you can just tell something is really wrong. I think I have a picture of the visible seams here. So you can see on the left side of this picture where it says, let's say the bottom where it says member states, where the B of member is, there's a seam going all the way up, and all the text is just offset. And we're probably talking about 10 microns, but you know, that's a problem. Ultimately, this was the result of me not adjusting for rotation. So when I started adjusting for rotation in the stitching, this problem went away. Currently, over 99% of all our photos stitch, 1% does not, and I still have to figure out why. I have some ideas on how to deal with it though. I want to employ different control point finding algorithms. So I'll take the default one first. If it doesn't work well or it doesn't find enough control points, which I have to write a script for to check, we will employ different control point findings. And I'm hoping that we will basically get this to 99.999% so that we don't have to worry about a case where it doesn't stitch, because that was kind of the things we really wanted to achieve in the project. Another challenge is speeding all of this up. You might remember that the subtitle of this presentation was digitizing microform at scale, which means that we want to do a lot of them and we want to do it quickly. Because if we have a single person do one fiche a minute, it's going to take 10 years, 15 years to digitize the microfiche we have, but we want to do it in 1 or 2 years. So we might have to get another machine and have people do it. I have several people do it 8 hours a day in different shifts. There's a lot of things I still have to speed up. One of them is the machine processing time. So stitching can still easily take a minute and a half, which is currently okay because it takes about 1.5 minutes to digitize a fiche. But we want to get that to like 25 seconds per fiche. So when we do that, the human operator and digitization is going to run ahead of the stitching process. So I'm going to use the GPUs that we have in the machine to offload a lot of the algorithms to the GPU so that we can stitch much faster and keep up with making the humans faster. And that's exactly the second point. So how do we get the digitization to go fast so that people can do many more fiche in an hour? Currently, there's a lot of things that are super obvious. When someone set up the machine, he installed Ubuntu on a hard disk, not on an SSD. And they have to migrate the whole setup to the SSD because we're mostly just waiting on the hard disk to write our gigapixel images. There's some other obvious blocking processes like reserving an identifier on the item. So reserving an item on the Internet Archive can take 15 seconds. Well, we don't really have to wait for that. The operator can just start scanning the next fiche, but currently they have to wait for that. And then finally, there's a lot more automation that we want to do to make, for example, find pages in the crop boxes better, more reliable, all that kind of stuff. I've only shown you the good ones, but the cropping also really fails in some cases. One of what I think is going to be the next big challenge is automating the metadata extraction from the title bar. So I'll try to quickly find the title bar here. Okay. So again, you can see there's a title in the middle of the title bar at the top. It says unclassified FPIS daily report East Asia, and on the right there's a number, and then there's a card number if there's more than one card, and on the left there's a date and various product codes or catalog numbers. Ideally, nobody would have to type that in. We would just see it. We just OCR the image and then we know what's on there. But that seems to be quite hard. First of all, getting the OCR to work well is tricky. A lot of these fonts are dot matrix fonts, so they're just dots as opposed to connected lines. And OCR cannot deal with that very well. Tesseract, we've retrained the models in Tesseract to deal with the dot matrix fonts, but it was still a problem. And there's a new project called EasyOCR, which does a much better job for this. What we then did is we said, okay, let's take the OCR output of the title bar and format it in, let's say, Notepad. Not actually Notepad, but you get the idea. And we add spaces where there's spaces, and we just take these few lines and we feed them to ChatGPT. And we ask it, okay, look, here's the prompt. This is what the title bar is, and can you please give us the date, the card number, the catalog number, and the title. And it turns out that the large language models are not that good at spatial representation within the text, which makes sense because that's, they don't have to deal with that most of the time. So what we're currently trying to do is we're trying to write some custom code to split up the title bars, use something called OpenFST to tag all these things, and then train a machine learning model called Layout LM, which is very good at understanding document layouts. Yeah, I'm almost done. And we will then use Layout LM to provide a more structured piece of information to a large language model like ChatGPT or Llama to get the information out of it. We're still working on this, but it's looking promising, but I think this might be eventually more challenging than the stitching. But we can proceed with the project now by just entering things manually. Yeah, so the next steps, like I said, make it faster, make it cheaper, improve the cropping, improve the metadata extraction, and we'll see if we have to change how our metadata works. The Internet Archive website is archive.org. I'm Merlijn at archive.org. Usually I have a link to all the source code of the files, but it's still in progress. But all the big stitching parts and all the digitization parts will eventually be put online. So if you have any questions about this, send me an email and I'll get back to you when we have it online. Thank you.
Okay, so if you have any questions, maybe you can talk with him outside the hall in the break, because we don't have enough time right now. Also, this is a small gift from us for you.
Thank you very much.
Thank you once again.